Hi all, welcome to Easy Max by everyone. You are learning integration. Let's see what we will cover in today's lecture. The topics that are covered in this lecture are a quick recap of previously learned concepts, solving few sums based on the standard results or theorems which we have learned in our previous lecture. You have learned three theorems in our last lecture. The first one was d by dx of integral f of x dx equal to f of x. The second theorem was integral k times f of x dx equal to k times integral f of x dx. And the third theorem was integral f1 of x plus f2 of x dx equal to integral f1 of x dx plus integral f2 of x dx. The second part is integral f1 of x minus f2 of x dx equal to integral f1 of x dx minus integral f2 of x dx. These two theorems can be collectively expressed and generalized as integral k1 f1 of x plus or minus k2 f2 of x plus or minus etc. plus or minus kn fn of x dx equal to k1 into integral f1 of x dx plus or minus k2 into integral f2 of x dx plus or minus etc. plus or minus kn integral fn of x dx. Let's see solving few sums using these theorems. Let's solve this sum. Integral x cube plus 4x square minus 3x minus 2 divided by x plus 2 into dx. Even if you split this integral like x cube by x plus 2 plus 4x square by x plus 2 etc., still you won't be having any formula support for this. So there is a different method of solving this. You must be aware of this long division method which we usually use to divide a polynomial by a binomial. So we have to use the same procedure here to divide the binomial by this binomial. So using long division method, we are going to divide x cube plus 4x square minus 3x minus 2 by x plus 2. And you know that procedure. You will be taking the first term of your dividend, divide it by the first term of your divisor. Whatever answer you are getting will be the first term of your quotient, right? So then taking that x square multiplying with our divisor, we have to write it against the next row. X square into x will be x power 3. X square into plus 2 will be plus 2x square. Subtracting this from that, changing the signs, we get x cube cancelled. Plus 4x square minus 2x square will be plus 2x square. Bring down the next term, minus 3x. Now this becomes our new dividend. Take the first term of the new dividend divided by the divisor. First term of the divisor, you will get 2x as the new quotient. So this becomes our next term of the quotient. Now multiplying our divisor with 2x and writing it against the next row, we get 2x into x will be 2x square, 2x into 2 will be 4x plus 4x. Subtracting, we get 2x square getting cancelled, minus 3x minus 4x will give you minus 7x. Bring down the next term, minus 2. Now dividing the new dividend's first term by the divisor, we get minus 7. This will be the next term of our quotient. So multiplying divisor with the newly obtained term minus 7, we get minus 7 into x become minus 7x, minus 7 into plus 2 become minus 14. Now subtracting, changing the signs, 7x get cancelled, minus 2 plus 14 will give you plus 12 as the remainder. So this is our remainder here and this is our quotient. We know by division algorithm. Division algorithm is used not just for numbers, it is used for polynomials as well. By division algorithm, we have this can also be written as dividend divided by divisor equal to quotient plus remainder by divisor. Both of these can be used. Okay, so now we are going to use this. So using our dividend and divisor in this rule, we get x power 3 plus 4x square minus 3x minus 2 divided by x plus 2 equal to, what is our quotient here? X square plus 2x minus 7 plus remainder is 12 by divisor is x plus 2. So instead of integrating this, we are going to integrate this. So putting integration sign, x power 3 plus 4x square minus 3x minus 2 divided by x plus 2 into dx equal to integral x square plus 2x minus 7 plus 12 by x plus 2, everything multiplied by dx. We can split this into individual integrals like x square dx plus taking out the constants out as well, 2 times integral x dx minus 7 into dx becomes minus 7 integral dx plus you can take 12 outside, integral dx by x plus 2. And of course you are familiar with the formulas to be used here. Integral x square will be x cube by 3 and 2 into integral x dx will be x square by 2 minus 7 into integral dx will be x plus 12 into, this is log of x plus 2, right? So log of x plus 2 plus constant of integration c. Let us solve the next sum. This sum is also solved using the same procedure as above, but you can observe something. There are some terms missing in the dividend. So you have to introduce dummy entries instead of them. So this is a must to do, because if you are not introducing dummy entries, you will get confused in the procedure. So x power 4, there is no x cube term, there is no x square term, there is no x term as well. So you have to enter dummy entries for them like 0x cube, 0x square, 0x. 1 is there. Dividing this by x square, there is no x term in our divisor as well. So introducing dummy entry for that, rewriting this. Now we have to follow the same procedure. So dividing the first term of the dividend by first term of the divisor, we get x square. So this will be the first term of our quotient. So multiplying divisor with the x square and writing it against the next row, we get x square into x square, x power 4. X square into 0x, that will be 0x cube only, plus x square into 1 will be 1x square. Now subtracting, changing the signs, x power 4 gets cancelled. 0x cube minus 0x cube brings you nothing. So you no need to write that. 0x square minus 1x square will give you minus 1x square. Bring down the next two terms together. So minus x square plus 0x plus 1. Now this is our new dividend. So take the first term of the new dividend and divide it by the divisor's first term. You will get minus 1. So minus 1 is the next term of our quotient. So multiplying the divisor with minus 1, we get minus 1 into x square is minus x square. Minus 1 into 0x is again 0x. Minus 1 into plus 1 is minus 1. Subtracting, changing signs, we get x square getting cancelled. 0x minus 0x brings you nothing, no need to write. Plus 1 will give you plus 2. So this will be our remainder here. And this is our quotient. So again by division algorithm, so using the given dividend and divisor, we get x power 4 plus 1 by x square plus 1 equal to, what is our quotient here? X square minus 1 plus remainder is 2 here. Divisor is x square plus 1. So instead of integrating this, we can integrate this. So integral x power 4 plus 1 by x square plus 1 dx equal to integral of x square minus 1 plus 2 by x square plus 1, everything multiplied by dx. Again, we can split this into individual integrals. Integral x square dx minus 1 into dx will be minus integral dx. Taking 2 outside, we get integral dx by x square plus 1. Now, using the respective formulas, we can get integral x square equal to x power 3 by 3 minus integral dx is x plus 2 times, you know, integral dx by x square plus 1 equal to tan inverse x. So, this will be 2 times tan inverse x plus constant of integration c. Let us solve this sum. Integral 1 divided by sin square x into cos square x dx. We are going to use the identity sin square x plus cos square x equal to 1. Replacing this 1 with this identity, we can rewrite this integral as sin square x plus cos square x divided by sin square x into cos square x dx. Now we are going to split this into two terms, like integral sin square x divided by sin square x into cos square x plus cos square x divided by sin square x into cos square x. Of course, dx is common to both of these. Now we can cancel sin square x and sin square x. Here cos square x and cos square x. So the remaining terms are 1 by cos square x plus 1 by sin square x into dx. Secant square x, 1 by sin square is cosecant square x into dx. Now you can split this into individual integrals, like integral secant square x dx plus integral cosecant square x dx. And there are direct answers for them, right? So tan x minus cot x plus constant of integration c. Let us solve this sum. Integral cos 2x by cos square x into sin square x dx. Here also we are going to use the identity for cos 2x. We know that cos 2x equal to cos square x minus sin square x, isn't it? So we can write the numerator using this value of cos 2x, like cos square x minus sin square x divided by cos square x into sin square x dx. Again, we can split them into two terms, like cos square x by cos square x into sin square x minus sin square x by cos square x into sin square x, and dx is common for both these terms. Again, we can cancel cos square x in the first term and sin square x in the second term. So remaining terms are 1 by sin square x minus 1 by cos square x, and dx is common for both of these. And again, we know that 1 by sin square is cosecant square x minus 1 by cos square is secant square x into dx. So we can split this into two individual integrals now. Integral cosecant square x dx minus integral secant square x dx. And this will become minus cot x minus secant square integral is tan x plus c. You can take the minus common and write it like minus of cot x plus tan x plus c as well. Let us solve this sum. Integral cos 2x minus cos 2 alpha divided by cos x minus cos alpha into dx. This sum also cannot be solved directly. Now we are going to use identities for solving this sum. We know that cos 2x equal to 2 cos square x minus 1, and similarly cos 2 alpha equal to 2 cos square alpha minus 1. Using these two values for cos 2x and cos 2 alpha, we can rewrite this integral as 2 cos square x minus 1 minus 2 cos square alpha minus 1 divided by cos x minus cos alpha into dx. Now subtracting the second term from the first term, we get 2 cos square x minus 1 minus 2 cos square alpha, minus of minus 1 will become plus 1 divided by cos x minus cos alpha into dx. So this minus 1 and plus 1 will cancel. So the remaining terms are 2 cos square x minus 2 cos square alpha divided by cos x minus cos alpha into dx. We can take the 2 common and bring it outside the integral. So this will become 2 times integral cos square x minus cos square alpha divided by cos x minus cos alpha dx. We know one identity which is a square minus b square, whose answer is a plus b into a minus b. Using this identity for cos square x minus cos square alpha, we can write this as cos x plus cos alpha into cos x minus cos alpha. Using that value here, we get cos square x minus cos square alpha equal to cos x plus cos alpha into cos x minus cos alpha divided by cos x minus cos alpha dx. Now you can see this term and this term entirely cancels. So we are left with 2 times integral of cos x plus cos alpha into dx. Now this can be easily split into two individual integrals. 2 times integral cos x dx plus 2 times integral cos alpha dx. So we know that integral cos x dx equal to sin x. So this will become 2 times sin x plus 2 into, when you are integrating with respect to x, cos alpha is treated as a constant only. So cos alpha can be taken outside. This is just integral dx only. So the answer for this will become 2 sin x plus 2 cos alpha into integral dx, answer is x, plus constant of integration c. This can also be written as 2 sin x plus 2x cos alpha plus c. Let us solve this sum. Integral sin power 6x plus cos power 6x divided by sin square x into cos square x dx. This also cannot be solved directly. We are going to use some algebraic identity here. We know this formula, a plus b whole cube equal to a cube plus 3a square b plus 3ab square plus b cube. This can also be written as, right? So we will be getting a plus b whole cube minus 3ab into a plus b equal to a cube plus b cube. So replacing a with sin square x and b with cos square x, we get sin square x plus cos square x whole power 3 minus 3 into a is sin square x b is cos square x into a plus b will be sin square x plus cos square x equal to a cube plus b cube. So sin square x is our a now to the power 3 plus cos square x to the power 3. So this becomes sin square plus cos square is 1. So this becomes 1 cube minus 3 sin square x into cos square x. Again this sin square plus cos square becomes 1 equal to sin square x whole power 3 becomes sin power 6x and cos square x whole power 3 becomes cos power 6x. So this is the value of sin power 6x plus cos power 6x. So rewrite this integral. Replace the numerator with 1 minus 3 sin square x cos square x divided by sin square x cos square x into dx. 1 by sin square x cos square x into dx minus 3 can be taken common. Integral sin square x cos square x divided by sin square x cos square x into dx. This 1 should be replaced with a sin square x plus cos square x divided by sin square x into cos square x dx minus 3. Here we can cancel sin square x and cos square x. We are just left with dx. This can be split into two terms like sin square x by sin square x cos square x dx plus I am splitting the integral as well, cos square x by sin square x into cos square x dx minus 3 integral dx. Now this sin square and sin square cancels, cos square and cos square cancels. We get integral 1 by cos square x dx plus integral 1 by sin square x dx minus 3 integral dx. 1 by cos square is secant square x. So integral secant square x plus 1 by sin square is cosecant square x dx minus 3 integral dx. This is equal to integral secant square is tan x and integral cosecant square is minus cot x minus 3 integral dx is x plus constant of integration c. Tan x minus cot x minus 3x plus c is the answer. That's all for this lecture. If you find this video useful, like it and share with your friends. Stay tuned for our upcoming videos. Thanks for watching.